Welcome back to Spring to Math 8. I'm Mr. Burns. Today we're going to be reviewing all the topics we've covered this far in our chapter. So let's take a look at the very first one. Converting decimals to fractions and fractions back to decimals. What's important for you to know is that whether it's a decimal form or fraction form, those two numbers can be considered equivalent or the same. They're just written in a different format. Let's take a look here. Fraction to decimal. We have the fraction 7/8. And 7/8 we're going to turn into a decimal by dividing the numerator by the denominator. In this case, 7 divided by 8. When we divide 7 by 8, we get the decimal 0.875. Now we can say clearly and confidently that the fraction 7/8 is equivalent to the decimal 0.875. Let's go back the other way from decimal to fraction. And we're going to talk about a little quick trick that you can use to help you when you're doing this. Because we have three numbers that come after our decimal, 875, we can confidently say that we have to put 3 zeros in our new denominator. So I can drop the 0 in the decimal, put 875 on the numerator of our new fraction, and put 1,000 as the denominator. So 875 over 1,000 is our new fraction. Topic 2. Identifying terminating and repeating decimals. Terminating decimals. Let's take a look at what that means. A terminating decimal is a decimal that ends or has a finite number of digits. And when I say finite, I mean that it has a very specific amount of digits and then the decimal is over. This can vary from 1 to 100 or even more, but it ends at some point. These two examples we have here, 0.75, that is equivalent to the fraction 3/4. And we got the decimal by dividing the numerator by the denominator. So 3 divided by 4 gives us that 0.75, and that's it for the decimal. That, therefore, means we have a terminating decimal. Our other example down at the bottom is 0.23985. That is also a terminating decimal. It does not repeat, and it just ends at that point. Repeating decimals. A repeating decimal is a decimal that has digits that repeat over and over forever. And you can indicate that digit repeats over and over by simply drawing a line over that digit and shortening your answer. So we have 0.3333. That 3 goes on forever, but no one wants to write that. So we shorten it by just putting 0.3 and simply putting a little line over the top of our decimal. That clearly indicates that 3 would continue on forever. Topic 3. Identifying rational and irrational numbers. What is a rational number? Well, a rational number is a number that can be written in the fraction format. And a fraction is already in fraction format, so therefore we can say that all fractions are rational numbers. You should also know that rational numbers can be both positive and negative. What is an irrational number? A number that cannot be made by dividing the two integers. So therefore, a decimal also that repeats goes on forever without repeating. Example, pi, 3.14, is an irrational number. What about square roots, you might ask? Well, a square root is a little bit confusing. It can be both rational and irrational. So let's take a look at the difference. For a rational square root, we have to have a number that breaks down completely to a whole number integer. Our example here is the square root of 49 is equal to the whole integer 7. 7 times 7 gives us that 49. So we are sure that 7 is our answer. And 7 can be turned into a fraction, 7 over 1, which if it can be turned into a fraction, we know that the number is a rational number. But square roots can also be irrational when they cannot be completely reduced to a whole number integer. For example, the square root of 2 is not a perfect whole square answer. It is approximately 1.41421 and so on. Now we can take that decimal and we can shorten it, and we can say that it has an approximate value of 1.5. Those two squiggly lines you see, those stand for approximate. So examples of rational numbers. Fractions, both positive and negative ones. Decimals can be both positive and negative. Terminating decimals, repeating decimals. And square roots that reduce completely to whole number answers. Those are examples of rational numbers. Examples of irrational numbers. Decimals that do not terminate or repeat. And the best example of that would be the pi, 3.14. Well, we all know that pi actually goes on forever and ever. And square roots that don't completely reduce to a whole number answer. Those are your examples of irrational numbers. Topic 4, decimal value of a radical number. What happens when you if you have a square root that does not have a whole number answer. So we need to take a look here at this example. The square root of 30. That does not break down to a whole number answer. So we need to figure out what two numbers it falls in between. I know that 5 times 5 is 25, and that is a little bit less than 30. 6 times 6 is 36, and that's a little bit more than 30. So we can say that the square root of 30 falls somewhere between the numbers 5 and 6. Last topic, guys, comparing rational and irrational numbers. To compare and order rational numbers, you should first convert them all to the same format: decimals, fractions, percentages, etc. In my opinion, the easiest way to compare things is where they're all in the decimal form, but everybody has their own liking. Let's review quickly those inequality signs we use to compare numbers: greater than, less than, greater than or equal to, or less than or equal to. That's it for today, guys. I wish you the best of luck. See you next time.